Hello and welcome back to Rust Learning by Example. Today we're focusing on Rustlings, which is a set of exercises provided by the Rust language people themselves that you can download via a crate and install on your computer and then run via a command line interface. When I last did this, I had just finished doing section 3, if statements, and now I'm on to primitive types. So, last time I was doing this, I think I was getting a little bit bored, a little bit sleepy. So I've decided that I'm going to change up the style a little bit and see how fast I can make it through the exercises, and also see how many times I can not use the reference. Okay, so let me just set up that. Right, so I'm going to try and see if I can keep this number low. Number of times accessed. Maybe I just have it in. Number of times I access the docs. At the moment it's 0, and then I will run timer, stopwatch. So let's see how quickly I can make it through. Next solution. Load this. I may as well read the README. Rust has a couple of basic types that are directly implemented into the compiler. In this section, we'll go through the most important ones. Data types and the slice type. This is a quiz for the following sections: variables, functions, if. Mary is buying apples. The price of an apple. What? Oh, it's. All right. I see. Mary is buying apples. The price of it. So this is basically a little quiz section before I move on to the next thing, I suppose. Anyway, Mary is buying apples. The price of an apple is calculated as follows: an apple costs 2 rust bucks. However, if Mary buys more than 40 apples, the price of each apple in the entire order is reduced to only 1 rust buck. Write a function that calculates the price of an order of apples given the quantity bought. Bam. Two goes to I32. If apples is less than 40 times 2, else apples. Test failed. There we go. Done. So yeah, pretty simple really. there's an if-else statement. If the number of apples is less than 40, then return apples times 2. If it's more than 40, just return apples because it's only worth 1. This is the signature, the function signature. So basically I'm just saying the apple's input is type integer 32, and then I'm going to be outputting the type integer 32. Okay. Next. So now we're on primitive types. Okay, so basically Rust has a couple of basic types that are directly implemented into the compiler. In this section, we'll go through the most important ones. Right. Let's load this then. To do, define a Boolean variable with the name isEvening before the if statement below. Ta-da! So you can explicitly define it, but I guess like the type is essentially inferred by the compiler. So you don't have to explicitly define it. I kind of want to read these things, but I guess I don't really have to. So okay, next. How quickly am I doing? 4 minutes so far. 4 minutes, 30 seconds. Okay. Note the single quotes. These are different from the double quotes you've been seeing around. Fine. What? Didn't know that was still going. Okay. Yeah, so you define characters using single quotes and strings using double quotes. What's the issue though? To do, analogous to the example before, declare a variable called your character below with your favorite character. My favorite character. Who has a favourite character? It'd be more likely to be a Greek character because that has more meaning in science and stuff. Love a Sigma. It's a good character. Sum operator. Z. Probably. Yeah. Yeah, it's got to be one of X, Y, or Z. Z. Then your own. Try an emoji. Oh, that's easier. What's my favourite emoji? I use this one all the time. Let's say this. Da, da, da. Yeah, I don't really... Okay. So it's just saying you can use lots of different types, I suppose. Chars can be all sorts, but you can't do something like this. No, 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 sir. No, no, no. Oops. Cool. All right. Next. Could not compile exercises bin primitive types 3 due to one previous error. To do, create an array called A with at least 100 elements in it. Let A equal 0 to 100. Wow, that's a big array. Oops, daisy. There's a thing there. That's just cheating. Okay, I have sort of seen this before, but not really, so I am going to go to the book. Access docs once. A certain data type. Oh, Christ, that's long. It means that it must know the types of all the variables control. Operations, the Boolean type, the character type, compound types, the array type. Okay. Data allocated on the stack rather than the heap. We'll discuss the stack and the heap more in chapter 4. When you want to ensure you always have a fixed number of elements. Initialize an array. Cool. So I guess if you did this stuff, if you did like, if you knew that you wanted an array that you were going to populate with values, but you wanted it assigned on the stack because it's a bit faster, you would just do like 0 or -1 times however long you want the array to be or something. Okay. Sure. Can use the following syntax. Cool. Okay, next. To do, create an array called A. No, already done that. To do, get a slice called nice slice. Two, three, four. So that would be A1, 2, 0, 1, 2, 3. Oops. Need to make sure that that is a reference. So this says that it's a thing. Actually, do you know what? I'm going to have to do it again because I don't understand why. Whoops. I don't really understand why you need that. Let's take off my top because it's getting way too hot. In fact, I'm going to open the window as well. Oh, that's better. Right. Where's those docs? Data types. Huh? Functions, comments, control, flow, slice type. This is probably anyway. Yeah. Slices let you reference a contiguous sequence of elements in collection rather than the whole collection. Contiguous means elements that are next to each other. They're one after the other. A slice is a kind of reference, so it does not have ownership. Here's a small programming problem. Reference to part of a string that looks like this. I mean, I think I know the answer to this. It's basically just because it's basically just a pointer at the start of a memory location. You can't hold the full thing. You can hold a pointer to the beginning of it, but as well check. But you'll often see string slices used in many contexts. String slice mutual reference to a sequence. I don't know. Can't be bothered to figure it out properly. All I know is that this works. And I think that's always a good place to start. Next. Where are we at? Let's see. 17 minutes 24. Okay. See if we can get through this in under 30 minutes. Destructure the cat tuple in one statement so that the print line works. Let your pattern here. Right, okay. Name age. Probably that. That's what's used in other stuff. I imagine that's what's used here. Yep. Easy. Good old tuple unpacking. I wonder if it would work if I did it like this. No, they don't like it. Okay, cool. This is like tuple assignment. That maps to that, and that maps to that. Experiment here. Use a tuple index to access the second element of numbers and assign it to a variable called second. See if that works. No, I don't like it. Use .1. That's really random. Like, why is it like that? Okay, so let's write this down somewhere. Okay. Don't need to do that. Let's come here. Finish that. Is that going to have anything? Data types. Has it got the tuple type in there? Oh no, I'm going again. Doc access is 3. How embarrassing. Tuple is a general way of grouping together that cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values, etc., etc. Binds to the entire tuple, single compound element. Yep. It's a design choice that provides a concise to access elements. Here are the key reasons: simplicity. Yeah, that's doesn't that's not very good. Okay. That makes sense. I guess you could also argue this also makes it clear when something is a tuple versus an array, improving code readability. Maybe. Okay. Is that only 3 or is it 4 now? Might be 4. Oh, no. Right, anyway. I've passed this, right? Yeah, passed it. Okay, primitive types basically done. 24 minutes. Under 30 minutes. Cool. Let's see what they said about this. It's quite funny with some of this stuff. You know, you could really, if you're not using a tuple, you could probably force data all over the place. Semantic clarity. Come on, there we go. Something like that. Okay. Right. Let's get started on Vec 1. I think I probably won't have time to finish this, but who knows. Boom. Oh no, preset. Start that. Section 5. Vex. Oops. 0. Let's see. Oh, there's only 2. Oh yeah, I should be able to finish that, no problem. Storing lists of values with vectors. Vectors are one of the most used Rust data structures. Another programming language is simply called arrays, but since Rust operates on a bit of a lower level, An array in Rust is stored on the stack, meaning it can't grow or shrink, and the size needs to be known at compile time. And a vector is stored in the heap where these restrictions do not apply, presumably via linked list. Vectors are a bit of a later chapter in the book, but we still think that they're useful enough to talk about them a bit earlier. We should be talking about the other useful data structure, hash maps, later. Hash maps are dictionaries, in case you're wondering. Okay. Again, why the heck? Anyway, first I reach one, I need to store something on the heap. Okay. Contiguous blocks of memory, contiguous blocks of memory that are stored on the heap instead of the stack. Because they're stored on the heap, they can be dynamically grown or shrunk. Decreased in size. Linked list because they don't contain pointers to the next item in the list. It's simply the next block of memory. Cool. Just going to check this. Okay. No, let's just see if I can finish it. Let's see if I can get it done. To do, create a vector called v, which contains the exact same elements as an array A. Why can't I just like tab that in? Anyway, whatever. Might have to use a for loop. Okay. I'm going to check. This is a vector with a generic type. So basically saying they need to establish what type it is. If you're not going to put anything in... Actually, I don't think you do need to do that. I don't think it is bad to do that. It just assumes, I think. Say vec growable arrays, heap allocated, efficient indexing, resizing, sure, linked lists and Rust doesn't provide a standard library that they are less commonly used due to performance trade-offs. Okay, so this is borrowing. I think that basically sums it up. Okay. Oh, I do have it here. So does that mean I can say vec that work? Maybe we want what about that? Hey! Nice. I wonder if that's even strictly necessary. Anyway, that's cool. There's always a faster way of doing these things. Nice. Next. ITA. Oh, right. Is this... What's this? 2 accesses. Item. Cool. And what was the other one? Map takes a closure and creates an iterator which calls that closure on each element. What is a closure again? Together enclosed with references to its surrounding state, the lexical environment. In other words, a closure gives you access to an outer function scope from an inner function. Basically, rather than just calling the function, get rid of all the references to variables in the function. Because you pass references to these variables. Okay. I'm not sure that really helps. Before I read that, let's have a look at, what was it? Mutation function is that? So it's lazy. This means lazy execution, which means like it will only execute if it has to. It doesn't execute everything. It executes when it's told to, rather than executing always, I think. Multiply each element in the input slice by 2 and push it to output. Is that it? Here we just want to multiply each element in the input slice by 2, but with iterator mapping instead of manually pushing into an empty vector. Interesting syntax. Expected closure that takes one argument. Right, okay. Capture variables from its closing scope. Closures are similar to functions but have the addition. Ah, right, I see. So I could do times x here. Yeah. Cool. Okay. Cool. And let's see, move semantics. I can probably get started on this. So 20 minutes roughly to do that. Let's go on section 6. Move semantics. Whatever the hell that is. Probably should save this, shouldn't I? These are pretty easy. Okay. So, oh yeah, how long did this take? Time, was it like 22 minutes or something? the issue? Vec.push88, right, cannot borrow as mutable. Fix the compiler, so I guess I've got to say let mute vec equal vec. I can optionally experiment here. Is that all it took? What's the readme? Get rid of that, get rid of that, get rid of that. What? Oh yeah. Right. See if that works. Nice. That was the README. These exercises are adapted from this place. For this section, the book links are especially important. Oh shit. Fine. I'm going to access them twice then. What is ownership? Oh my god. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that compiler checks. If any rules are violated, your program will compile or slow down your program while it's running. Because ownership is a new concept, it does take some time to get used to. The good news is the more experience you become with the Rust, the more ownership system. Blah, blah, blah. Nice references and borrowing. What's the bet? I don't need to know this to complete these exercises. Let's see if I can just do this one. And then I'm gonna end, I believe. Yeah, I'll end roughly here. So what have we got? Semantics to fill vec mut push 88. You can optionally experiment here. What's the issue? What? I can't touch this parameter takes. Oh right, I see. So it's saying. Consider changing this parameter type of function to borrow instead of of. Oh, if. No, I was wrong. What does that mean? I could do that. Okay. Nope, I actually may have to read it. God damn it. Okay, this is a good place to stop. Hope you've enjoyed this. I imagine this might take me a bit longer to go through because explicit ownership isn't something I've really come across before. So, yeah. Looks interesting. Okay. Bye.